In the previous video, we did an example involving a piston cylinder system in order to get some practice using and manipulating energy balances. I want to return to that system in order to give you some practice in using what I'll call force balances. Okay? And so what I'll do here is first let's consider or reconsider the system in which we have a gas inside a piston cylinder. And so we have our cylinder, and we have some sort of gas underneath the piston. Okay? All right? And so I'll say that the piston has, it's not a, weightless piston. It's going to be made of metal or something. And so it's going to have a mass. I'll also say that the piston has some sort of cross-sectional surface area too, as well. All right, and so underneath the piston we have a gas. Right? And outside the piston, it's not in a vacuum. Let's just say it's at atmospheric conditions. All right, and so above the piston, it's at atmospheric pressure. All right, and so in this sort of example, what I'm going to say is that our piston, it's not moving around or fluctuating in position. Let's say that it's stationary. Right? And so this is similar to what we had in the previous problem, where we just had a piston above a gas. But really, when we consider this system, this sort of begs the question. If our piston isn't weightless and has some sort of mass, why doesn't the weight of the piston, why doesn't it just completely squish the gas, right? The weight of the piston just completely, why is it being suspended in the air? Right? Why doesn't it just go all the way to the bottom? Okay? All right, and so this is a question that I have. So what I want you to do is I want you to pause the video and I want you to consider why or what the answer to this question is. All right, and so the piston doesn't completely squish the gas. In fact, it's suspended above the gas. And the reason for that is because the gas is exerting an equal but opposite force against the piston. So because the gas is exerting an equal but opposite force against the piston. Okay? All right. And so that's the answer, but what do I mean by that? All right? And to at least explain this more clearly, I want to zoom in on the sort of things that are occurring right where the gas meets the piston. Okay? All right, and so let me space this out a little bit better. So let's zoom in to get a closer look. All right, and so here's our piston. All right, and underneath our piston we have gas molecules. Right? And these gas molecules aren't stationary; they're moving all around. And a lot of times the gas molecules will be moving in a direction such that they bounce right into the piston itself. So system molecules. Okay. All right. And so, because these gas molecules are bouncing all around and bouncing up, what they do is they impart a force upwards against that piston. All right, and that's due to collisions of gas molecules against piston. Okay. All right. So the gas molecules are bouncing or moving upwards, and when they hit the piston, they impart a force that goes upward. Now, of course, the piston isn't flying upwards to infinity, right? And that's because there are also forces that are acting downward as well, okay? And so, the first thing we need to consider is that the piston has mass, right? And so, the piston itself, there's a downward force because of the weight of piston. Right? Gravity is pulling it down. So that's acting in the downward direction. All right, but that's not the only thing that is causing the piston to go down. All right? The other reason, or the other force that's causing the piston to go down, is actually due to the atmosphere. Right? And so here, I said that above the piston, it was at atmospheric pressure. Right? And so what that implies is that, above the piston, it's not a vacuum, right? There's nothing there. What's imparting that atmospheric pressure is actually also gas molecules of air going downwards. Right? So those are also going in the downward direction. And so what we have is the force down, or downward forces that are due to weight of piston and collision of atmosphere particles downward. Okay? Okay? And so we have a force up and we have a force down. Right? And if the force up is equal in magnitude to the force down, that means that we're in what we call mechanical equilibrium, such that, the piston doesn't move anymore. It's stationary because the two forces are balanced against each other. All right? And so if force up and force down are equal in magnitude, that means the system is in mechanical equilibrium. Okay? All right. And so that's qualitatively what's happening. All right? But in order to get a more quantitative understanding, we need to relate these forces to things that we could actually measure. All right? And so let's talk about what each of the forces are equal to. All right? So our force up, right, that's going to be related to the gas pressure. All right? Right, and so I'll say F up, force up, right? For that, it's going to be equal to the pressure of the gas times that surface area of the piston. All right? And why can I say this? Well, we have to remember what the units of pressure are, right? All the way back in Chapter 5, I mentioned that, pressure, for example, if we have it in units of Pascal, those units are just equal to Newton over meter squared, right? And so newtons, which are a unit of force, over length squared, which is an area. So if we multiply the gas pressure times a relevant area, which in this case would be the surface area of the piston, that will give us the force that's acting, that the gas is imparting on the piston. Right? And so the units that we'll get here will be Newton. All right, in a similar manner, if we consider the force down, the two factors that impact the force down are the weight of the piston plus the force of the atmospheric gas particles. The weight of the piston, as you'll remember, is just the mass of the piston times the gravitational force divided by gc, depending on the units that you have, and then plus the atmospheric pressure times the surface area of the piston. All right? So that's similar. The gas acting downward has a similar form as the gas acting upward. In any case, since we're in equal mechanical equilibrium, what we have is force up is equal to force down. All right, and so what we have here now is we could say pressure of the gas times surface area of the piston is equal to the mass of the piston times g over gc plus the atmospheric pressure times the area of the piston. All right? And so from here, what we did, I'll circle this, is we did a force balance. And by doing this force balance, now we have a way to relate the pressure of the gas inside the cylinder with the mass of the cylinder and also the pressure outside of it. Okay? And so we're going to use this as a tool for helping us solve some of our energy balance problems.